We can't turn gravity off at the surface of the Earth, and we can't turn it on up in space. So what happens if we try to live without it? Could astronauts adapt to a life in microgravity permanently? These are 12 steps towards creating artificial gravity, and this is number 2. Why do we need gravity? Astronauts on the ISS, they're not in zero gravity. They're in free fall, constantly falling around the Earth, moving so fast sideways that they never hit the ground. They feel weightless, but Earth's gravity up there is still about 90% as strong as it is down here. What's missing is the support force, the pressure that tells your body which way down is. Now, our bodies evolved in 1G. 4 billion years of life have tuned every organ, every bone, every blood vessel to that constant downward load. Remove that and the body doesn't adapt, it starts dismantling itself. Without gravity, the first thing to go is the structure. Bones lose the constant stress that keeps them strong. So density drops about 1 to 2% per month. That's about 10% in 6 months. That's several years of osteoporosis happening in just half a year. The skeleton literally starts dissolving because it's no longer under load. And then as that skeleton weakens, the muscles follow. Legs will go first because you're not walking or standing. And even with 2 hours of daily resistance training, astronauts lose about 20 to 30% of their lower body muscle mass in around half a year. Then the heart begins to drift. It doesn't have to fight gravity to move blood upwards, so it relaxes, shrinks slightly, and loses power. Blood volume falls. Back on Earth, when astronauts try to stand up, the blood pools in their legs and they can faint. Meanwhile, the body's fluids shift towards the head. Faces puff up, pressure builds behind the eyes, and the backs of the eyeballs flatten so vision gets blurry. So a Mars mission, that's not 6 months. It's over 2 years. You've got 6 to 9 months to get there, you've got time on the surface, and you've got 6 to 9 months coming back. Exercise isn't enough. Medication can help, but it doesn't solve it. If you take gravity away for long enough, human biology starts drifting away from what we recognize. For long missions, we need gravity. But we can't make it the way nature does. Maybe science fiction might have a few ideas. But that's for the next episode. Stay nerdy.